All right, so we have got mass down. We got it figured out. Let's talk a little bit about volume. Does the mass of an object always affect the volume of an object? What is the volume of an object? What does that even mean? We talked a little bit the other day about a ping pong ball and a golf ball. Now, they were the same size, but one was a lot heavier. So the mass was different. What do we know about that? Well, to start off with, we need to figure out that what volume is. And volume is simply the amount of space that an object takes up. So bigger objects have a bigger volume. Smaller objects have a smaller volume. If you look at a basketball and a baseball, which one has a bigger volume? Which one takes up more space? It would be the basketball, okay? So when you look at a golf ball and a ping pong ball, they would have pretty equal volumes, but different masses still. We measure volume with a couple of different tools. We can measure volume with a beaker, which is shown here on the left, or a graduated cylinder, which is shown here on the right. Depending on how you want to measure your liquids will determine which one of these tools is going to be better for you. The glass here, the beaker is not a very accurate measuring tool. So if you say, well, you need about 100 milliliters of water, you could measure them with a beaker as long as you didn't need an exact 100 milliliters of water. If your lab procedure says, you know what, you better get exactly 32.5 milliliters of water, you're going to want to use a graduated cylinder because graduated cylinders are narrower and they have more lines on the side. Notice all these tiny lines compared to there's only like 10 total on this one. There's about 100 of them on this one. Because of those little lines and because it's narrower, you get a more accurate reading from a graduated cylinder. So for the most part, we're going to want to be using graduated cylinders to measure our liquid water. What units do we use when measuring volume? Well, the metric unit for volume is what we call a liter. To get an idea of what a liter is, you think of a 2-liter pop bottle. That's obviously twice as big as a liter. You can also buy a liter pop bottle and that would be exactly a liter. A lot of times in chemistry we aren't going to need that much liquid for what we're doing, so we usually measure them in a different unit, which is 1/1000th of a liter. That's called a milliliter. And a milliliter is about a dropper full of liquid. Okay? One thing that we need to know is that a milliliter is exactly the same amount of liquid as a cubic centimeter. By definition, they're the same. We also say that a centimeters cubed is another way that we refer to that. So when we're measuring the volume, like I said, we're always going to use a graduated cylinder. Why? Because it's more of an accurate measurement. Now, when you're looking at a graduated cylinder and measuring, you're going to see something called the meniscus. And we're not talking about your knee, we're talking about the liquid. Now, because of the properties of water, which is what we'll mostly be measuring, you get this curve in the top of the water. That curve is called a meniscus. And it's really important that we know which part of this we're going to read. Because if some of us read the top, we'd get a different measurement here than if we read the bottom. When we read a meniscus, we are always going to read from the bottom of the meniscus. So here's the curve in the water, and at the very lowest point in the middle, that's where you're going to take your reading from. If you're measuring the top, you're always going to have too much in there. Okay? Now, when you're looking at it, here's a closer up view. Here's your eye over here. Here's the meniscus. You need to get your eye right at the same level as that liquid so you can look straight across. If you're standing up and looking down at it, you're going to get a reading that is too low. And if you're below it looking up, you're going to get a reading that's too high. So in order to be accurate, you need to be right down at eye level. So you leave your graduated cylinder sitting on the lab table, and you just bend yourself down and take a look straight across, and you'll get a very accurate measurement that way. So let's practice reading these then. Here's a graduated cylinder. Okay, and the first thing we're going to want to figure out is what is each mark worth? Now when we ask that, we're asking about these little marks along the side. So as you're looking at each, what are we counting up by each time? Are we counting by ones, twos, tens? The way that we figure this out is, okay, we're starting at 0 here and 10. How many marks does it take for us to go from 0 to 10? And you go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 marks. That means each mark is worth 1 milliliter. Okay? What is the maximum value that the container can measure? Well, for a graduated cylinder, we're just going to look at whatever that very top line is. So the most water that we can measure in here would be 50 milliliters. And then we need to know exactly how much liquid is actually in this graduated cylinder. So we look here, in green is the meniscus drawn, and if you remember, we're going to read from the bottom of the meniscus, which is down here. Okay, so you look across, and we got, this is 30, this is 31, 32, 33, so it's kind of 32, 33 right in there. We're going to say 33 milliliters, okay? Let's try another one here. This time, so we're looking, we go from 0 to 1 here, and if we count these marks, we'll see that there's 10 marks between 0 and 1. That means that each of these little marks is 1/10 of a milliliter. Okay, because we took 1 and divided it by 10. 1/10 as a decimal is 0.1. The maximum value we can read in here, again, we look at our top line here. That's 10 milliliters. That's the top. And we are going to read the volume in here. Here's our meniscus. We read it from the bottom. It's pretty close here to this line, which is 4. And then we count 4.1, 0.2, 0.3, 0.4. 4.5 looks like about the right answer. It's a little hard to tell on this drawing. You might have said 4.6, and that's okay too. Try this one on your own. Work through, figure out what each mark is worth, find the maximum value, and record the volume of that green meniscus right there. Pause the video, try it on your own, and then check your answers. All right, hopefully you got them all right. If you have any questions, of course, you can email Miss B, and she'll get back to you as soon as she can. Otherwise, I will see you soon.